Hello everybody and welcome back to another video on my channel. Today we will be talking about a very important quantity in physics that goes along the lines of momentum. So without further ado, let's move on to the video. Well, there are a few things that we all know. We know that momentum is equal to mass times velocity. We know it's also equal to force times time. From my last video, we were also talking about how Newton's second law really is that force is a change in moment, or no, not force. Force causes a change in momentum. But what would that change represent? Change represent? Well, that would be impulse. Impulse, which is often denoted as J, is equal to the change in momentum, or it's force times change in time, or it's also equal to mass times change in velocity. So that's pretty much it, and that's what impulse actually is. But the biggest thing is that instead of just being like a change in momentum, it represents basically all the action done by forces. If you remember in my last video about Newton's laws and their connection to momentum, we talked about how in Newton's second law, again, force is change in momentum, but the third law, we're talking about how everything has an equal and opposite force. Every action has an equal and opposite reaction, and basically, instead of saying equal and opposite reaction, in this case, we could say equal and opposite impulse. This over here is also a very valid definition of Newton's third law. Another very powerful application of impulse is how it can predict many different scenarios. So let's run through a few of them. Let's say I'm trying to catch a ball. Now let's draw a diagram over here. We have a ball that's coming to us over here that's trying to catch it. Now there are two main ways we could approach this. Either keep our hand in front of us and rigid. So basically, there will be a very low amount of time, but since it's the same momentum, the ball has the same mass and the same speed, the force is going to be maximized. That's why it hurts, or we could kind of catch with the ball or give in to the ball. As what we'd be doing then is we would be observing the force but instead of absorbing the force as we normally say, we would just be spreading that same amount of force over a larger interval of time, thus still canceling out that momentum and energy. Now, there are many different examples, but this is just a very good example which explains momentum's, or really impulse's, connection to force. The biggest takeaway, though, that I want people to know is that momentum is kind of like impulse is kind of like the dose of force. How much of it over how much time, and that is really what predicts all of motion instead of just the force that applies on it. So, thank you so much for watching this video. See you in the next one, and bye-bye.